Yes girls, after completing practice set 2.1, you can see soon after that there is a representation of irrational number on the number line. I am sure you have studied this in the 8th standard. I'll just revise with you the process because it might be one of the question in your paper to represent these numbers on a number line. So you have to have an idea how to represent these numbers on the number line. Is that very clear? So now we have root 2, right? So you know root 2 is an irrational number. We saw that. So how do we represent root 2 on a number line? Yes, I hope you remember, you have done this. So you are also doing along with me. 0 to 1. See girls, here you have to take a scale. You can take a scale of 1 unit is equal to 2 centimeter or 3 centimeter according to your convenience and the page what you have. So if I take 1 unit as suppose 2 centimeter. Okay, I know what is root 2. We have seen the root 2 value. Root 2 value is something 1.41 ... recurring, right? So it is non-recurring number, so we don't know what is further, but we are sure that it is greater than 1 and less than 2. So it lies between 1 and 2. So you will take 2 centimeter here. You will also mark 2. Again, what is the distance between these two? 2 centimeter. So you will keep this ready, and after that you will draw perpendicular. Okay, you will draw. So I mark these points by writing that is a point. So 0 is a coordinate. I mark this point by writing a letter A. So 1 is a coordinate. Is that clear? At this one, I drop a perpendicular. How can I draw perpendicular? There are many ways. You can use a set square, you can use a protractor, you can use a compass. Whichever is easier for you, you can adopt that method and show the perpendicular. Is that clear? Whatever is this 1 unit, same you will take on this. That means if I am marking a point B on this ray, then it has to be OA is equal to AB. Is that very clear? Now, after doing that, I hope you can see a right angle triangle. Then I join OB. Followed. After doing that, taking O as a center and OB as the radius. I repeat, O as a center, OB as the radius. We will draw a circle. And in that process, what happens is when the circle is going, it will touch the number line down. Wherever it touches the number line, here you have is root 2. As it is touching through the positive side, the same will go and even touch the negative side. You can see that when you move the compass to the other side, to the negative side of the number line, there you will have your minus root 2. Is that clear? So this is how we draw root 2. Suppose if we have to do root 3. Yes. To do root 3? Yes. Come on. Very good. We draw a perpendicular at this point. See, whenever I take a new point, I have to name that point. This is my point A, and this will be the new point which I have is C. So C coordinate is, the coordinate of C is root 2. And what is distance AC now? Distance AC is root 2. Is that very clear? Followed. Whenever we compare, we distance from O, right? From 0. So greater coordinate minus smaller coordinate. The distance is root 2. Now at root 2, I can draw root 3. Process is the same. That is, you will take this 1 unit. Again, I repeat, not root 2. You will take 1 unit. Is that very clear? From point C, whatever is this 1 unit, that is your 2 centimeter, you will keep at point C and mark it here. That becomes your point D. Okay? Yes. Taking OD as a radius, OD. So I join OD. Taking OD as the radius and O as a center, you will again draw a circle. So you have here root 3. This is your root 3. Same way, when you put it on the other side, on the negative number line, you will have your minus root 3. Got it, girls? So you have learned to represent root 2, root 3. You have to also know how to represent many more irrational numbers on the number line. If the rational numbers are given, do you know how to represent? Yes, you have to know that also, how to represent rational numbers on the number line. Like 1, 1 upon 2, 3 upon 2. All these basics you have studied in 8th standard, girls, already. So it is just I am revising with you. And now we go further to further part of the chapter, that is about irrational number. Now coming to irrational number, turn to page number 22. You can see irrational and real numbers. So what are irrational numbers? As we already seen, which are non-recurring and non-terminating numbers are irrational. Come to the definition of real number, page number 22, come to the last paragraph there. Every point on a number line is associated with a unique real number. And every real number is associated with every unique point on the number line. So what are number lines? Numbers which are represented. That means it is a combination of all natural numbers, whole numbers, integers, rational numbers. What else? Yes, irrational number together is what is called as real number. So real number is a bigger set compared to all the other sets. Now, every real number may not be a rational number. That is true. We saw it is a combination, right? Now coming to page number 23, mark the definition of irrational. Non-terminating, non-recurring decimals are called as irrational numbers. Is that very clear? Properties of irrational number. Addition or subtraction of a rational number with the irrational number is an irrational number. That means if I have a rational number added to an irrational number, what is this number? This is an irrational number. Is that very clear? Same way, multiplication or division of non-zero rational number with irrational number. That means if I have 3 divided by root 2, this is also an irrational number. Keep this in mind, girls. These properties will be useful when we are doing certain types of sums from the exercise. Further, addition, subtraction, multiplication of 2 irrational number. That means if I add 2 irrational numbers, sometimes it will be a rational number, sometimes it may be a irrational number. So there are difference in both. You will find as you do sums, you will understand these properties further when we take up some examples. But keep in mind the 3 properties because that is very, very important to start with the further things. Coming to the properties of order relation on real numbers. Yes, you can see there are, what is the meaning of order relation? Yes, girls, we had seen this before also. Descending order, ascending order, right? These things are not new to you, right? I think ascending, descending order you are studying from right from your KG class. That is how you start, no? 2 is smaller, 3 is greater, then you say the next number. So ascending, descending order is very much known to you. Is that clear? So now here if you have two real numbers, A and B, what is possible? Either they are equal or A is less than B or A is greater than B. So let us take one example, suppose 2 and 5. 2 and 5 are 2 real numbers. Now among these 2 real numbers, which relation among these will exist? Yes, it will be 2 is less than 5. So it is or, either or, either this or this or this. All three is not possible with one set of numbers. Is that very clear? Going for the second property, if A is less than B and B is also less than C, so what can I say is, this gives me the resultant A is less than C. Simple example, 2 is less than 4, agreed. 4 is less than 6, right? So it's not that 2 is less than 6. Got it? So these are the properties which you have to remember for order relation of real numbers. Coming next, same way, if I have A less than B, then if I add a number, a real number to either side, if I add a real number C to either side, what happens? Whatever might be the number C, what you will find is it is always remains same. That is A plus C is also less than B plus C. Take any example, positive, negative, any numbers. You see, putting any examples, you will find it is one and the same. The relation maintains. But that is for addition. But if it is multiplication, yes. If it is multiplication, then what happens? Let us have a look at it. I have two numbers A and B. A is less than B. Okay. So if C is positive, then when I multiply AC and BC, the relation remains the same. Let us see one example after I tell you the further property. If C is negative, what happens? This sign reverses. So you get AC is greater than BC. Now let us see one example. Suppose I have, you can give me positive, negative, there is no harm in that. But I am taking simple numbers so that is easy for you to correlate, girls. So 2 is less than 5. Right? So for the first one, C is positive. So let us take C as suppose 3. Easier for multiplying, right? Table of 3 is very easy. Okay, so what do you get? 2 3s are and 5 3s are. Can you tell me which is greater, which is smaller here? Yes, 2 3s are is correct, 6. 3 5s are is 15. So is it not that this remains as it is? So this is what you find here. This remains as it is. Now let us take C to be a negative number. Yes, can anyone suggest? -2. Ready? Okay. Now, what is 2 into -2 and 5 into -2? What is 2 into -2? We get it as -4. Correct. What is 2 5s are? 10, but a -10. Now tell me which number is greater. What has happened now? This has got reversed because -4 is greater than -10. If you understand this concept, it will help you to do the further exercise sums much faster. So these are the properties on order relation. And other than that, all the properties what is followed by rational numbers and irrational numbers, commutative, associative, distributive, all those properties what we had seen in the start is followed by the real numbers also. Coming next, keep this in mind. Square root of a negative real number is not a real number. Please underline this sentence. As well as there is something more I want you to mark. Square of any real number is always non-negative. Square root of a negative real number is negative, but square of every real number is always non-negative. Keep this in mind, 2 points which is correlated there. And with that we go to the exercise 2.2.